day one, day two. Today's day one, tomorrow's day two. So we're going to talk about writing an equation of a circle, which we did a little bit in geometry. And then eventually we're going to talk about getting into graphing a circle. What would that look like on a coordinate plane? Okay. And I think we might have done that just a little bit in geometry as well. And a lot of people will say, well, how does this tie into algebra? Because this is geometry, right? This is graphing a circle. This is a geometric figure. And it's mainly because of the equation. The equation is an algebra equation. And we'll do some algebra to get to the format that we want to make the circle equation or eventually the ellipse equation what we want. Okay, so as we work through this, we'll have more and more algebra that we're going to kind of mix in with what we're doing. There's 4 different kinds of conic sections, and it gets its name because if you take a cone and you make a section or slice that cone in different ways, you can make different shapes. And we're not going to get real in depth with all 4. The 2 that we're going to spend the most time with is a circle. Circle is where you take the cone and slice right through the middle, and if you look at both sides on the inside, it would be the same thing. Okay, the inside of both of the pieces of the cone would be the same shape, which would be a circle on the edge of it. If I were to slice through diagonally through that cone, then it's going to make what we call an ellipse. An ellipse is really just like an elongated circle. A lot of people call it an oval, but ellipse would be the mathematical term that we're going to use. Okay. If I go vertically down through that cone, then the outside portions would look like that, which is, yep, and if it's a U shape, what do we call that? Any graph that makes a U shape is called a parabola. Okay, and then this one here is the one that we haven't really talked about before. You've probably seen graphs of something like this back in Algebra 2 a little bit, but maybe hadn't heard this term of it. This is what we call a hyperbola. Parabola and hyperbola are the 2 that we're not going to really spend a ton of time with. I'll do it because it's on the first part of the notes here, because it's kind of an intro into all 4 conic sections. But these are the 2 that we're going to spend our majority of our time with these last couple of weeks. Okay, the standard form of equation of a circle. I think you've seen this before, probably going back to your geometry days. In geometry, sometimes we might use like the distance formula to find the length of the radius or the length of the diameter or something like that of a circle. But there's 2 things about a circle that we got to know. Okay, we have to know what its center is, and we have to know what its radius is. And sometimes they may give us the diameter, and we use the diameter to find the radius. But the generic equation of a circle looks like this. Way back in chapter 1, we talked about this formula. We had just a few quick questions about an equation of a circle, and so we've seen it. We just didn't really do a lot with it. They gave us an equation in this format. We identified the center. We identified the radius. The center is your h and your k value. And it's going to be just like we have done with different types of transformations. If I said x minus 2, then h is going to be a positive 2 because my h value is 2. So it's x minus whatever the h value is. So it's always going to be the opposite of this. If it was x plus 3, my h value would be negative 3. So it's always going to be the opposite of what that value is there. Same thing for k. Y minus k, the opposite of that would be the k value. If it's y minus 2, my k value is 2. If it's y plus 2, my k value would be negative 2. And then your radius is always r. But when we write it in the equation, we always write it as r squared. So if my radius is 3, this would be a 9 right here. We always square it when we put it back into the equation. Okay, so that's our generic equation. That's what we're going to be using a lot today to write the equation of a circle. And so we're not going to do all of these examples because they all kind of tie in with one another. On this first one, this is my h, this is my k, this is obviously my r. Those are the three things that I need when I write the equation. So when I write this one, I'm just going to go x minus negative 4, which is really x plus 4. Always a plus sign in between. Okay, that's one thing you can't forget to do. It's always a plus sign in between when we have a circle. And then y minus 6. Both of these parentheses are always squared. So don't forget to put the squared there. That's a big part of the equation. Equals 4 squared, and we're just going to go ahead and square it and make 16. That's our equation. Nothing else that we have to do. Okay, we don't have to FOIL it or anything like that. That's our equation. Okay, I'm going to jump down to number 4. Okay, because my radius is a little different here. This is h, this is k, and this is r. So we're going to go x minus 9 squared plus, okay, and then when I write my y value here, I could do y minus 0. But do I really need to do y minus 0? Because what happens if I subtract 0? It's just y, right? And so typically you won't see that written. We're just going to write this as y squared because we don't really need to put the y minus 0 in there. So just know anytime you have just an x or a y by itself, then the h or k associated with that would just be 0. Okay, same thing could be true for the x value. If I just have an x squared, then the h value connected to that would be 0. Okay, now here's the part that is a little bit tricky. If I square 5 radical 3, it's been a while since we've dealt with some radicals. When I square 5 radical 3, I got to square both numbers. When I square 5, I get 25. What happens when I square radical 3? Radical just goes away. So this is 25 times 3, which would be 75. And that would be my equation. But the key here is that you got to multiply those two things together. And you have to square them both. Because 5 radical 3 in parentheses, you're going to square both terms that are in there. There's no plus or minus sign in there with it. It's just squaring both of those terms. Okay, so that's just writing the equation. Okay, next one that we're going to do is write the equation based on the graph. So here they don't just come right out and say, here's my center, here's my radius. So what we're going to do here is we're going to find the center and the radius. Okay, the center is this point right here, right in the middle of the circle. And we got to figure out what the ordered pair of that center is going to be. It's just an ordered pair, right? So we're going to start at 0, 0, and we're going to go left 1, 2, 3, and we're going to go down 1, 2, 3, 4. So left 3, down 4. My center is at negative 3, negative 4. The radius is how far the graph goes from the center to the edge of the circle. Doesn't matter what direction I go. Well, you could go up, left, down, or right. You cannot go diagonally. The reason we can't go diagonally is because we can't count diagonally. So you want to count either vertically or horizontally. So you want to go left, right, up, or down. And it doesn't matter what direction I go because the radius is the same in all directions. In this case, my radius is 2. 2 units from the center to the edge. Okay, when I write my equation then, this would be x plus 3 squared plus y plus 4 squared equals 2 squared, which is 4. Okay, try number 6. See if you can come up with the equation for number 6. All right, my center is where? 0, 1. Okay, my radius is 6 units. Okay, 6 units counting from the center to the edge of the circle. How would we write the first part with the x?
X squared.
Just x squared, right? We don't need to write x minus 0, so we're just going to write it x squared. Plus y minus 1 squared equals 6 squared. That's all there is to it. Okay. On ones like that, we're probably going to give you a radius that is pretty easy to count, right? We're not going to give you like one that's a decimal or a radical, because that would be pretty hard to be able to identify where that would be. Look something like this one over here. We would write it as like 5 radical 3. If I wanted to know what the radius would be, then we probably would leave it in simplest radical form. But in this one here, okay, for these next couple of problems, there's 2 things that we're going to need, and we haven't used these for a little while. We're going to need the distance formula. And we're going to need the midpoint formula. Okay, both of those are formulas that we've seen many, many times throughout the years. Probably a lot in geometry, but we've seen them this year. We used it a little bit at the beginning of the year. Midpoint distance. Distance is used in a lot of different scenarios. Midpoint, maybe not quite as much, but just finding the halfway point. Okay. The reason we need those 2, first of all, if I have a circle that looks like this, if I were to give you the center and an endpoint, the distance between the center and the endpoint is going to be my radius. Okay, that point, that length right there is my radius. So if I can find the length or the distance between these 2 points, that would be my radius. They're not coming right out and giving me my radius, unfortunately, right? So we have to find out what that radius is, and in order to find that radius, we have to do the distance formula. Okay, so we got to take the 2 ordered pairs that they give me for that. And we know that this is my center. So we already know that part of the equation. And if you wanted to, you could go ahead and write that part out. You could say x plus 2 squared plus y minus 6 squared equals, but we're missing the radius, right? We don't know the radius, so we can't finish the equation out because we don't know that. So that's where the distance formula comes into play. We're going to use the distance formula to find that radius, and then we can finish out our equation. So to do the distance formula here, x2 minus x1. You got to really be careful of your signs here. Negative 4 minus a negative 2 would be negative 4 plus 2. And then y2 minus y1 would be 12 minus 6 squared. Negative 4 plus 2 would be negative 2. Negative 2 squared would be 4. Remember, that should always be a positive, because when you square a number, it should always be a positive. No negatives right here. 12 minus 6 is 6, and then that would be 36. So here, D is radical 40. Okay, and I'm going to show you a little trick here. Typically, we could break this radical down, and we could get it into simplest radical form, right? And if we did that, we don't necessarily need to do that, because if I take the square root of 40, and then when I put it back into my equation, all I'm really going to do is square it. So what happens when I square the square root of 40? 40. And that would be the same thing if I simplified that. Square root of 40 could be 4 times 10. And if I simplified it, that would be 2 radical 10. So we would say that this is the radius. That would be the simplified version of the radius. But if I squared 2 radical 10, guess what? It's still going to give me 40, right? So there's really no reason to simplify the radical unless they're asking you what is the radius in simplest radical form, okay? And so I wouldn't go through that work and do all of that. I would just square the radical 40 and get me back to 40 for the equation, and that's it. Okay, all of these are the same problem. They give you a center, they give you an endpoint, so these essentially are all the same thing. But if they give me the center, I know the h and k, I just have to find radius. So I don't think we really need to do another one of those. You guys feel pretty good about that? Just applying the distance formula. Okay, this last group of problems down here are all kind of the same as well. They're giving me 2 endpoints. Hey, what do we call that length right there? Diameter. Okay. That is the diameter of the circle. I'm going to write out diameter here so you don't think D is distance. D is diameter of a circle because it's the length all the way across going through the center of, and it tells me that right here. Otherwise, if it's just 2 random points that don't go through the center, we wouldn't know for sure if it's the diameter or not. That goes back to geometry, and like for instance, if I had 2 points here and here, those do not make the diameter because they don't go through the center. So it has to go through the center, and that's why it's also important. Okay, because we know this is the diameter, we know it goes through the center of the circle. So here, there's 2 things that we have to find. We have to find the center, and we have to find the radius. We don't know either one. Okay. I also really can't count from -1/8 over to 5/6. I can make a piece of graph paper and I can count, but if it's diagonal, I can't count, right? And so that doesn't really help me. But I'm going to show you what I think is the easier way to find the radius. I wouldn't go about doing the distance right now because that gives me the diameter. We want the radius. And some of you would say, well, all we'd have to do is divide by 2, but what if it's like a decimal or other things? And so that's why I'm going to hold off on the radius for just a second. The first thing that we're going to find here is the center. the center is the halfway point of this diameter. So if these are my two endpoints and it goes through the center, that center is going to be halfway in the middle, right? We also call that the midpoint of that segment. So that's where the midpoint formula is going to come in. We're going to go -1 plus 5 over 2, and we're going to go 8 plus 6 over 2. And we just got to do a little bit of math. A -1 plus 5 is 4. 4 divided by 2 is 2. 8 plus 6 is 14. 14 divided by 2 would be 7. That's my center. That's this point right here in the middle. Okay, to find my radius, I could find the distance between the center and either of the endpoints. So I could go from 2, 7, and I could go to this point, or I could go from 2, 7 and go to this point. Okay, you could go either way. And I think that's the easier way to go. It wouldn't be wrong if you use these two to find the distance and then divided it by 2, but I think it's easier to take the center and one of these 2 points, right? So, which one would be better to use? -1/8 or 5/6? I think 5/6, mainly because it doesn't have a negative in it, right? I try to stay away from negatives if at all possible, because there's more errors that could be made when you have negatives in there, okay? Just easy things that can happen. So to find the radius, I'm going to find the distance between 2, 7 and 5, 6. And we're going to plug that into the distance formula kind of like we did on the previous problem. So we're going to do 5 minus 2 squared plus 6 minus 7 squared. Which would be radical 10. Okay, so to finish up here, my equation would be, here's your h and your k value up here. X minus 2 squared plus y minus 7 squared equals radical 10 squared, which is 10. And that's our answer. Okay. These other three, like I said, are very similar. Okay? They give you the 2 endpoints, and you have to find both the radius and the center. That's it. That's our notes for today.